Section 4.1 Graphs of the sine and cosine functions. Periodic functions. Many things in daily life repeat with a predictable pattern, such as weather, times, and hours of day and night. And this is the periodic graph represent a normal heartbeat. You could see they're gonna going up, going down, and then keep constant, and then going up and going down again. They do repeat this pattern, right? This is called periodic functions. A periodic function is a function f such that f of x equal to f of x plus np. For every real number x in the domain of f, every integer n will be the integer, and some positive real number p. The least possible positive value of p is the period of the function. So p is talking about like the period. The circumference of the unit circle is 2 pi. So the unit circle is 360, means like 2 pi. So the least possible value of p for which the sine and cosine functions repeat is 2 pi. Therefore, the sine cosine function are periodic function with period 2 pi, and the following statements are true for every integer n. So let's say I have the sine x, and I know sine x is a periodic function. So I could rewrite it to sine x plus n, that would be integer, times 2 pi, because one circle is going to be the 2 pi. So think about it. If I have a sine 30, I could say sine 30 plus n equal to 1 times 2 pi. So 2 pi is talking about 360. So 360 times 30, that would be 390. So they're talking about the same angle. It's just like the n, they go in one circle. When n equal to 2, it means going to be going for one more circle. Same idea with the cosine x. Okay, let's look at the sine function, fx equal to sine x. I do have the x coordinate here already, and I want you guys try to plug it in to see what you're gonna get for your y. So for example, when x equals 0, sine 0, that will be equal to 0. Okay, sine pi over 6, what's gonna be equal to? 30 degree. Sine 30 degree equal to 1/2. Okay, I want you guys try to fill in this table first. Okay, check your work. You should have a work 2 over 2, work 3 over 2, 1, 0, -1, and 0. Now, I want you guys try to use this coordinate to graph the sine x. You should have the graph like this. Okay, 0, 0. And then pi over 6, 30 degree is about 1/2, half of them. And then 45 degree, so half of it. So somewhere like here. Okay, and then you're gonna see the graph is gonna be a smooth curve. I should supposed to have the positive part here. But since I know the sine x is a periodical functions, so I could copy it, extend it to the negative side as well. Okay, right? So first, think about it. What is the domain? Domain is talking about the possible values of x. So you could keep extended here and here also, right? So the domain will be from negative infinity to positive infinity. And then the range. Range is talking about the possible values of y. So you could see my graph is only going like that way. I could draw the straight line here and also here. Right? You could see the blue curve is only go inside the two red lines. So I know that my range will be from -1 to +1. Okay, so look at the graph in here. Okay, I just only consider this part, okay, and make it bigger. So first, you're gonna see the intercept. It's gonna be 0, 0, pi 0, and 2 pi over 0. And then we do have the maximum value. Maximum value, the highest point, okay? It can be pi over 2 and 1 or -3 pi over 2 and 1. So the minimum is going to be here, right? The lowest point. So that will be 3 pi over 2 and the -1. Also, -pi over 2 and -1. That is also the minimum value. And then my sine curve is going to be starting from 0, 0, going up, going down, and then going up again. So you could see this part here. We call this as a one full period. If I keep working on it, there will be another period. So my full period is going to be equal to 2 pi. And when I divide it by half, the half period, so I'm going to divide it by 2 for this guy. That will be equal to pi. And then when I divide it by 2 again, that's called quarter period. So that will be pi over 2. And then we call this point as a 3/4 period because when you multiply by 3, you have a 1, 2, 3. So it's going to be 3 pi over 2. Okay. So the graph is continuous over its entire domain from -infinity to +infinity. Its x-intercept are of the form n pi, where n is the integer. So you could plug in n equal to 0, so the x-intercept will be 0. When n equal to 1, so you're going to have a pi here. When n equal to 2, you do have a 2 pi. So its x-intercept can be written in the form n pi. So the period is 2 pi. So they're starting from 0, 0, going up, going down, and then going up again, go back to the original points. Okay, so if I keep going on it, that will be the second period. So the period is going to be 2 pi, the distance from here to here. That will be 2 pi. And the graph is symmetric with respect to the origin. So the function is an arc function. So arc function, sine -x, that will be equal to -sine x. So sine x, the sine curve, that will be arc function. Okay, right? I need you guys to know how to draw the sine curve. This is the basic curve. Okay? Okay, cosine function. Okay, cosine function. This time, let's graph the f of x equal to cosine x. Okay, cosine curve. Let's try to graph f of x equal to cosine x. First, I want you guys try fill in this table. Okay, check your work. Cosine 0 is going to be equal to 1, right 3 over 2, right 2 over 2, and 1/2. Okay, cosine 90 degree. Okay, right? So based on these coordinates, I want you guys try to sketch the cosine curve. Okay, you should have this picture. And then, what is the domain for the cosine x? You could keep extending, right? Here and here. So the domain will be from negative infinity to positive infinity. How about the range, the possible values of y? Same idea, right? If I draw the line here, the range, it has to be in between -1 to 1. Okay, so the maximum point for the cosine, that will be 0 and 1 here, or 2 pi and 1. Minimum, that will be pi and -1 here. Okay, that's a little bit different from sine. Sine is starting from 0, 0, go up, go down, and then go up again, right? And for the cosine, they starting with the 0, 1, and then going down and then going up. Same idea. So starting from this point, going down and then going up, I go back to the original points again. So this is gonna be one period. And my one period, that will be equal to 2 pi. Same as the sine curve. And then you could divide it by half. So half period will be pi. Divided by half again. So a quarter period, that will be pi over 2. And then we could multiply by 3. So 3 pi over 2, that will be 3/4 period. Okay, so this is going to be y equal to cosine x. One more time, you guys need to know how to graph the y equal to cosine x without using this table. Okay, one more time. The graph is continuous over its entire domain from negative infinity to positive infinity. And then its x-intercept. Okay, x-intercept this time is that we going to pi over 2 and 3 pi over 2. So the form will be 2n plus 1 times pi over 2. When n equal to 0, that will be 0 plus 1 times pi over 2, which is going to be pi over 2. When n equal to 1, so that will be 3 pi over 2. And then the period is going to be 2 pi. Starting from here, go to here. That will be 2 pi. And the graph is symmetric with respect to the y-axis. So the function is even function. Okay, even function. So cosine negative x, that will be equal to cosine positive x. Sine function will be the odd function. Cosine function will be the even function. Okay, example. Graph y equal to 2 sine x and compare to the graph of y equal to sine x. You guys should know how to graph the sine x already, right? But before that, I just want you guys try to complete this table. Okay, check your work. For y equal to 2 sine x, you could multiply by 2 for this number. So that will be 0 times 2, that will be 2 times 0, that will be 0 times 2, negative 2, and 0. Okay, so when I try to sketch these two graphs together, you're gonna see that the red one, that will be my y equal to sine x. Okay, so that's the first example that we graph it together, this one. And then the blue one, y equal to 2 sine x. That's exactly the same thing, but I just multiply by 2. So you're gonna see that they do have the same x-intercept here. Okay, but when you have the maximum and the minimum value, instead of using 1, that will become the 2 here. This is a -1, that will become the -2. Okay, so think about it. If I have y equal to 4 sine x, what's the curve looks like? 4 sine x, then it will be going the same x-intercept. It's just like the maximum and the minimum point, that will be go to 4. So it will be going up 4, going down -4, and then going up again. Same idea, both of the curve, they do have the period. It's going to be 2 pi. So this is a one cycle, 2 pi. Okay, definition of amplitude of sine and cosine curve. The amplitude of y equal to a sine x and y equal to a cosine x represent half the distance between the maximum and the minimum values of the function is given by. So how can we find the amplitude? We're going to look at the number in front of the sine or cosine. And then amplitude is always positive. That's why we're going to put the absolute value here. Okay, so when you look at the graph, you can see that here, that would be your amplitude. Here also amplitude. Okay, so from this picture, your amplitude should be equal to 3. A equal to 3. A equal to 3 here. Example 2, graph y equal to 1/2 cosine x and y equal to 3 cosine x compared to the graph of y equal to cosine x. Okay, I want you guys try to do it by yourself. Okay, now let's do it together. First, I will try to graph y equal to cosine x. So I know cosine x, one period is going to be equal to 2 pi. And then 2 pi, I would divide it by half. 2 pi divided by 2, so I'm going to get the pi. And then I'm going to divide it by 2 again, so pi over 2. And then I times 3, which is going to be 3 pi over 2. So cosine is always starting from 1. Okay, this is a 1, 2, 3, -1, -2, and -3. So the coordinate should be 1, 0, -1, 0, +1. So my cosine curve is going to be going up, going down like this. So write down the name, y equal to cosine x. Okay, right? Now, I can use the green color to graph y equal to 1/2 cosine x. So 1/2 cosine x, that will be half of it. So I'm going to do the same thing. 0 doesn't change. Here, 1/2, 1/2. So my cosine curve is going to be, looks like this. Okay, y equal to 1/2 cosine x. And then let me do y equal to 3 cosine x. So the amplitude, equal to 3. So it's going to be 3 here, 0, 3 here, 0, and then 3 here. So my graph is going to be, looks like this. Okay, so y equal to 3 cosine x. Okay, right? Okay, one more. If I want to graph one is called y equal to -2 cosine x. What do you guys think? So the amplitude is going to be always equal to 2. So So the amplitude is going to be equal to 2. It's always positive. Okay, remember that. We're going to put the absolute value for that. And then negative 2. So we're going to say this is going to be the refraction. Okay, so when we have 1 here, that will become negative 2. 0, still 0. This one, when it's a negative 1, it will become positive 2. 0 again, and this is a positive 1, that will become negative 2 again. So my graph is going to be going like this. Okay, so this is y equal to negative 2 cosine x. So you can see when a is a positive here, we call this a no refraction. But when your a here, that's a negative number, then that's a refraction. Okay? Go back to your PowerPoint. You're gonna see this. Okay, period of sine and cosine function. Let B be a positive real number. The period of y equal to a sine bx. And then y equal to a cosine bx is given by amplitude, always positive. So you could find out the absolute value of the a here. That would be your amplitude. So same idea with the sine and cosine. Refraction upside down. If a is a positive value, that's a no refraction, just like the previous example. But if a is less than 0, then yes, that's a refraction on it. Same idea for this guy. And then the period, x distance of one complete cycle. How can we find the period? Period, that will be equal to 2 pi over b. Okay, 2 pi over b. We're going to find your b here. Same idea with the cosine. Y-intercept, starting point. Remember, sine is always starting from 0, 0. Okay, cosine, that will be starting from 0 and a. Okay, it's supposed to be, if you have an original cosine x, y equal to cosine x, then a will be equal to 1. Okay? Okay, let's try to do it together. Graph one cycle of y equal to sine x over 2 by first identifying the amplitude, refraction, period, and the y-intercept. So amplitude, we're going to look at here. A sine bx, right? So a here, that will be equal to 1. Refraction, since this is a positive, so that's a no refraction. Okay, period. How can we calculate the period? That will be 2 pi over b, right? So what is your b? B is talking about this guy. Okay, bx. So you could tell the b will be equal to 1/2. Okay, I could rewrite it to sine 1/2 and x. So b equal to 1/2. Okay, so here you could times 2, which is going to be 4 pi. And then y-intercept, since this is a sine curve, so intercept is going to be starting from 0, 0. Okay? Okay, after we have this information, we try to graph the y equal to sine x over 2. So first, you know the period is equal to 4 pi. So we're going to put 4 pi here. Okay, one period, that will be equal to 4 pi. And then we're going to determine the half period. So divided by half. 4 pi divided by 2, which is going to be 2 pi. And then we're going to divide it by 2 again. So that will be pi here. And then this is a quarter period. So you're going to times 3. 3/4 period. So 3 pi. Okay, and my amplitude is going to be equal to 1. So I will just put 1 here. Now, My y-intercept is always starting from 0, 0. And then here, pi and 1, 2 pi, 3 pi, and 4 pi here. Okay. So my graph is gonna be looks like this. So write down the name, y equal to sine x over 2. Okay. I just need you guys graph one cycle for this example. Okay, 4 pi, 2 pi, pi, and 3 pi. Okay, try this example. Graph one cycle of y equal to -5 cosine 4x by first identifying amplitude, refraction, period, and y-intercept. I want you guys try. Find out ABCD first, and then we could graph together. Okay, check your work. Amplitude A equal to 5. Okay, keep in mind amplitude is always positive. Refraction, since this is a negative, so yes, we do have the refraction. And then period. So you're gonna calculate it 2 pi over b. And your b, which is gonna be 4. So 2 pi over 4 means pi over 2. Y-intercept, since we do have the cosine, so it's supposed to be 0 and a. Okay, but we do have the refraction, so that will be 0 and -5. Okay, right? Now, okay, first, the amplitude is 5. So I'm gonna put +5 and -5 here. And then the period is gonna be pi over 2. So I'm gonna put pi over 2 here. And then we're gonna determine the half period. You could divide it by 2, but since we do have the fraction here, every time when you guys have the fraction, if you want to divide it by 2, you could do multiply by 1/2. Okay, multiply by 1/2. So that will be pi over 4. And then again, divided by 2, so I'm gonna multiply by 1/2 here. So which is gonna be pi over 8. And then the 3/4 period. So we're gonna be times 3 here. So 3 pi over 8. Make sure you guys know how to find these 4 numbers. Okay? And then y-intercept. This is the refraction. So we're gonna be starting from 0, -5. And then pi over 8. And then pi over 4. 3 pi over 8. And pi over 2. Okay, right? That's a cosine curve. It's going to be upside down because it's a -5. And then join all the points together. Write down the name. Okay, right? Try another example. Okay, check it. Amplitude A equal to 1. And then do we have a refraction? No, right? Because this is a positive. And then period 2 pi over b. Your b will be equal to 2 over 3 here. So that will be 3 pi. And then y-intercept, since this is a cosine curve, so, and we don't have the refraction, so that'll be 0 and 1. Okay, so 3 pi, so starting from here, that'll be 3 pi. Okay, so amplitude equal to 1. Let's label this one positive 1 and negative 1. And then period is going to be 3 pi. So we have the 3 pi here. And then half period, that will be 3 pi over 2. And then half period again. So you're going to be multiplied by 1/2. So which is going to be 3 pi over 4. And then times 3 here, that will be 9 pi over 4. Okay, y-intercept starting from 0 and 1. And then we're going to be going down here. Okay, join the lines together. Okay. Okay, try the example 6. Okay, amplitude equal to 2. Refraction, yes, right? Because that's a negative. Period, 2 pi over b, and your b equal to 3. Y-intercept. Since this is a sine curve, so that'll be 0, 0. Okay, right? Now, we're starting from the amplitude. This is a 2, right? So 2 and negative 2. Period, 2 pi over 3. And then one more time, we're supposed to be divided by 2 because this is the fraction. So I'm going to multiply by 1/2. Times 1/2, that will be pi over 3. Times 1/2 again, pi over 6. And then we're going to times 3 here. So that will be pi over 2. So y-intercept starting from 0, 0. Okay, and then we have the refraction. So we are not going up. We're going to be going down. Okay, draw the lines together. Write down the name. Okay, example 7. Try it one more time. Okay, amplitude A equal to 3. Refraction? Yes, because it's a negative. Period 2 pi over b. And this time, your b will be equal to pi. So the period should be equal to 2. Y-intercept, since we have a cosine, so supposed to be 0 and 3. But because it's a refraction, so 0, negative 3. Okay. Well done, the amplitude should be 3 and negative 3 here. And then the period starting from 2. So divided by 2, we're going to get 1 here. Divided by 2, we get 1/2. Times 3, that will be 3 over 2. And then y-intercept, we started with 0 and negative 3. Okay, going up. Join the curve together. Okay, the second cycle. To create a second cycle of the function, we make 4 more evenly spaced marks and use the standard counting unit to label each mark. So for the previous example, we only need you guys graph one cycle. How about if I want you guys graph the second cycle? Then how can you guys find all those numbers? So let's say the 2 pi, that will be my 1 period. Okay, we're gonna use half and half method to label the first 3x mark. So 2 pi, we're gonna find out the half period, so we divide it by 2. So that will be pi here. And then find out the quarter period, divided by 2 again. And then find out the 3/4 period, so we times 3 here. Okay, right? And then write the multiples of the first label above the x-axis, and then write the simplified form below. Okay, so try to write the multiples. First one is going to be pi over 2. Okay, second one, that will be 2 pi over 2. And then 3 pi over 2, we just add up the number. We keep the fraction here. So 1, 2, 3, and then 4 pi over 2, 5 pi over 2, until you get 8 pi over 2. And then now we're gonna simplify it. So these two cancel, I got the pi. This is good. 3 pi over 2, 3 pi over 2. 4 pi divided by 2, which is 2 pi. So I'm really good on here, right? I could check my work. And then 5 pi over 2, I could keep this guy. 6 pi divided by 2, I got the 3 pi. And then 7 pi over 2, and the last one, that will be the 4 pi. So this is how you guys figure out the second cycle of the function. Okay, you guys should be good for the first part here. And then whatever you have this graph, you could just extend it. Then you will have 2 cycles of the curve. Okay, let's try to do the example together. Given the periods as shown on the graph, label the first 3 x-axis mark, then label the last 4 marks. Simplify whenever possible. Want you guys try? Okay, check your work. So this one divided by 2. So I multiply by 1/2. Okay, so that will be 4 pi over 3. And then I gonna times 1/2 again. So that will be 2 pi over 3. And then I'm gonna be multiplied by 3. So that will be 2 pi. Okay, then I'm gonna write down the multiples. The first one, that will be 2 pi over 3. So multiples of 2 pi, that will be 4 pi over 3. And then 6 pi over 3, 8 pi over 3. 10 pi over 3, 12, 14, 16. Okay, now simplify. Double check your work. This is good. I simplify it. Good. This one, I can't simplify it. This one, that will be 4 pi, right? I can't simplify this guy. And this one, I can't simplify it either. Okay, right? So look at the multiples of this guy. Keep the fractions. And simplify it. You could double check your work for the first part here. Okay, B. Do the same thing. Divided by 2 or multiply by 1/2. Multiply by 1/2 times 3. Okay, right? So this time, the first guy will be 3 pi over 16. And then the multiple of 3 pi, that will be 6 pi over 16. And then 9 pi over 16, 12 pi of 16, 15, 18, 21, 24. Okay, simplify it. I can't simplify this guy. This one, that will be 9 pi over 8. Can't simplify this one. And then 3 pi over 2. Okay. Okay, graph 2 cycles of y equal to negative 2 sine 3 over 2x. Okay, by finding ABCD, same thing. So first, I want you guys to find out the amplitude, refraction period, and y-intercept first. So amplitude equal to 2. Any refraction? Yes, right? Because I'm negative. Period. So that will be 2 pi over b. Your b will be 3 over 2. Simplify it. You're going to get 4 pi over 3. Y-intercept. So since this is a sine curve, so that will be 0, 0. Okay, on the graph, I will have 2 and negative 2 here. And then I'm starting with 4 pi over 3. So first, we're going to determine the first 3 part here. So I'm going to times 1/2. So 2 pi over 3 times 1/2 pi over 3. Times 3, I will have a pi here. Okay, we're going to do the same thing, right? I do have a pi over 3. Find out the multiples of pi. So it will be 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8. And then I'm going to simplify, if you can. Now, my curve is going to be starting from 0, 0. Okay. And then, since I have the refraction, so I'll be going down here. Going up. Keep doing the same thing. Join all the points together. Write down the name. Okay, so I do have 2 cycles of this graph here. Example 10. Determine an equation of the form y equal to a cosine bx or y equal to a sine bx, where b greater than 0 for the given graph. So I have the graph here, and then I could use this graph to answer this question. What is the amplitude? The highest point, that will be 2. Here is also the 2, right? So a equal to 2. Refraction. So think about it. This one, it looks like the cosine, right? But the cosine is going up here. So they do have the refraction, yes. Since we do have the amplitude equal to 2, and they do have the refraction, so we could believe this guy, A will be equal to -2. Now, we're going to determine the period. Period is going to be starting from 0 until here. So the period will be equal to 4 pi. So we need to figure out the B here using the period. So 4 pi, that will be equal to 2 pi over B. Okay, solve for your B. You should get 1/2. Okay, we already know this is gonna be the cosine curve. We have the A, we have the B already. Okay, and also the y-intercept, that will be from 0 and -2. Okay, so the equation will be -2 cosine 1/2 x. That's it.